This is the Chapter 8 Combination Circuit Math handout, problem number 2. So we see here at the top we're going to have a total of 3 drawings. We start with our original drawing here that we were given, and we're going to do a couple of redraws in order to find the total resistance of this circuit. So to begin with, we fill in our known values. We were given 30 volts, and we were given all of our resistance values: 250, 800, 1K, and 2.5K. Since this is a combination circuit, we cannot add all these together. We cannot reciprocate all of these because some of them are in parallel, some of them are in series. So what we have to do is figure out what is in parallel and what is in series. So if we look at the circuit here, we can see that these two are in parallel with the voltage source, and these two are in series with the voltage source. So my first redraw, I'm going to combine R1 and R2, giving me 1.05K ohms. I just simply add them together because those are two resistors in series. Here I have 1K ohm and 2.5K ohm in parallel, so to combine R3 and R4, I have to use the reciprocal formula. So on the calculator, hit 1 over under 1 over under 1 times 10 to the third. Scroll over, plus 1 over under 2.5 times 10 to the third. Hit equals, hit engineering, and it's 714.29 ohms. That's what this value is right here. So that leaves me with 1.05K ohms in series with 714.29 ohms. Two resistors in series, so I'm just going to add those two together to give me my total amount of resistance right here. So my total amount of resistance for this circuit is 1.76K ohms. And here's the steps that I'm taking to solve the circuit. So number 1, RT. Anytime I can get 2 out of 3 going horizontally, I can solve for the third. So now I've got my voltage and my resistance. So I can solve for IT. 30 volts divided by 1.76 times 10 to the third ohms gives me a total current of 17.05 milliamps. Now, if I look at the construction of the circuit, I understand that from point A to point B is the main branch. All of the current will flow from A to B. From E to F is the main branch, so all of the current must flow from E to F. And since R1 and R2 are on the main branch, that tells me that I1 and I2 are also going to be 17.05 milliamps. All right, now I've got 2 out of 3 for V1 and 2 out of 3 for V2. So I take the 17.05 milliamps times 250 ohms. This gives me the value of V1, 4.26 volts. Now I want to find V2. I'll change the 250 ohms to 800 ohms. 13.64 milliamps. Now, R3 and R4 are in parallel with the voltage source. So that tells me that V3 and V4 will be equal. They will be the same amount of voltage. V3 will equal V4. But since I dropped some voltage at V1 and I dropped some voltage at V2, I have to take that out of the total in order to find the value of V3 and V4. So V3 will equal V4, which will equal the total voltage here minus V1 plus V2. And that tells me that both of those voltage amounts will be 12.1 volts. Now I can find I3 using Ohm's law, 12.1 volts over 1 k ohm, 12.1 milliamps, 12.1 volts over 2.5 k ohms gives me 4.84 milliamps. Let's look at our steps. So we solved for RT, then we solved for IT, I1 and I2, then we did V1, V2, V3, V4, I3, I4, and now we're going to do all of our powers. And it's very important to write these steps down. That way you'll know how to solve the problem if you get stuck. So PT is equal to IT times VT. So I just put the 17.05 times 10 to the negative third milliamps in there, times 30 volts, 511.5 milliwatts. Then when I get ready to find P1, I do I1 times V1. P2 is I2 times V2. P3 is I3 times V3. P4 is I4 times V4. And on your answer sheet found in Canvas, these are the answers I'm looking for. So you'll punch these numbers into the answer sheet on Canvas.